We are trying to find this dy, I guess the relationship between x and y. So find the original function y, right? If we get the derivative looking like this. So what happens is we need to integrate this, all right? We've got kind of one function here. Let's say it's equal to, let's say f is equal to x squared, and the other one, f prime, is equal to 2x. All right, I'm going to color them for simplicity's sake. And so what happens is we've got this function here, and then the red function is the differentiated one. Okay, now that could even be like, I don't know, like something like plus 3 or something. But for now, I'll just leave it as a simple case. And so what happens is we get given the differentiated one, and so we're wanting to integrate it to find the actual value of the white one. Okay, so we're going to have to integrate this, and whenever we integrate, we get given this plus c value. Okay, because we don't know what like if there's a constant value added to our x squared, right? We're just trying to find the gradient here, and so if we have something like plus 3 here, we differentiate that, that 2 gets brought down to the bottom, but that 3 just disappears. So that 3 could actually be a 4, or it could be a 17. You don't know. So that's why we need to get given a point, and then we'll solve it. So let's integrate sine x plus e to the x. Okay, and we can split this up. So whenever we see a plus sign or a negative sign and we see two separate terms, we can split the integral across that. Now you will do this in your head, but probably not formally. I like writing it out just to explain to people. Okay, now we got two separate problems. Okay, this sign will flip to a cos when we integrate it. But the problem is it a negative or is it a positive? So how I remember it is now just differentiate that value. So bring it back down and flip it back. Now if you differentiate cos and it becomes a sine, you differentiate, you go down and it's sines and it's sinning, I guess. We can use some theological explanation here. If it's a like sinning, it's bad, it's going to hell, then it gets a negative sign. So we need to keep a negative sign here because when we differentiate cos, it will become sine, and it sins and it's bad, and we need a negative sign. Now that doesn't look the same as our original value here, does it? That doesn't look the same. We've got this random negative sign there. So we need to add a negative sign here. Okay, let me remove all of that. Now that we've done that, we are going to do this really easy one, which is what is the integral of e to the x? Now, e is a funky number. It's that 2.7, and it just stays the same. You know, it's immune. Now we just need to write that plus c because, again, we're not sure if it's a plus 4, a plus 3, a plus 17. So now we can say that y is equal to cos of x plus e to the x plus c. We're not quite done, are we? We haven't found y yet because we've got this random value here plus c that could be anything. So you've given an infinite number of solutions. Let's do one more. We're given a point here. We're given a point to say when x is equal to 0, y is equal to 0. And we can see if we substitute those two values in, all we're left is with c. So we can say sub and solve for c. Okay, so 0 is equal to minus cos 0 plus e to the 0 plus c. All right. Now, when we have our unit circle, I like to remember we need to crawl, which is our x-axis, before we can touch the sky. Okay, so in this case, if we go 0 degrees around, we're here, our value is 1 and 0. Now, because cos is all about the shadow on the x-axis, because you're crawling, that means that this value here is equal to 1. Okay, so that's, not sure if that's an easy way for you to remember it, but that's how I like to remember it. The next is that e to the power of 0, anything to the power of 0 is equal to 1. Okay, and then really simply, we can see that minus 1 plus 1 is equal to 0. So we can say c is equal to 0. The final result, therefore, is equal to minus cos of x plus e to the x plus 0. And so that is our final result. If you have any questions, reach out. I love to help. I've got so many more questions on my website. You can go on there, the link's below, and you can practice as many as you want to get the best marks that you can. I'd love to hear from you guys. Reach out.